So good afternoon to one and all. In the last class, we have discussed about the linearity, accuracy, dead zone, dead time, and all the things we have discussed. It's the static characteristics, dynamic characteristics we have discussed. So anyone, can you tell me what is the difference between static and dynamic characteristics of measuring instrument? Yes. Roll number 44.
Yes, sir.
Can you differentiate static and dynamic? Static characteristics of a measuring instrument means what? I don't know. See, listen carefully, all of you. I am not expecting you from exact answer. What you know, what you understood, you just tell me. That's it. So number 44.
Which does not change with respect to time. Static characteristics.
Okay. Roll number 22. Akshay. Kale Akshay. Akshay Kale. Roll number 22. Akshay Kale. I will put absent and I will remove you from the meeting if you're not responding. Number 22. Roll number 22. Once again, I'm calling you Akshay. Kale Akshay. I will remove. Okay. Roll number 19. Rushikesh. Doke Rushikesh. What do you mean by dynamic characteristics? Roll number 17. Roll number 17. Govind.
Yes, sir.
Tell the answer fast. Roll number 14. Wagmanir Shruti. Shrutika. Roll number 14.
Yes, sir.
So then what you people are doing? You're not studying at all then. See, we have already discussed static characteristics, the quantity which will not vary with time. It's almost constant or negligibly small, we are going to call. The quantity which is vary with time, that is called dynamic, which will become constant, that is called static characteristics we have discussed. With that, static and dynamic characteristics, we have also discussed about the accuracy. Accuracy is nothing but whatever the measuring quantity is there, the closeness to the standard value, that is called accurate value, or accuracy, we are going to call that one. Closeness of the measuring quantity with the standard or true value, we are going to call, that is called accuracy, we are going to call. Linearity, anyone? What do you mean by linearity? The output is linearly proportional to the input. This is linearity. Whatever the diagram it is seeing here, this is linearly proportional only. We are going to call linearity only. Just some students joined. I will admit them. Number 9, 21. So this one, whatever we are seeing here, see here, input is 0. Input is 0. What is the output? Here input is 0 is there here. Okay. At this point, what is the input and output?
0.
0. I will increase, this is the input. I will increase some point here now. Then output should have to increase same quantity. It should have to increase here now linearly. See here, this is the input. The output is at this point. What is the value of that point here? That is the output here. Yes, linear now. It is linear or not? Next, the input I will consider from here to here. See here, that point, and from here to here we can join that one. Linearly increasing. So the output is linearly proportional to the input. That is called linearity. We are going to call. That is called linearity. Linearity we are going to call. That one, the dead zone, dead time. If you increase the input, but the output will not be changed, that time taken to change the output is called dead time. We are going to call. Whatever from this point to this value is there, when the output we got that one, that is called dead zone. We are going to call that one. That is called dead zone. Like that, we have discussed accuracy, linearity, dead zone, dead time in the last class. Today we are going to discuss this one. Also I have explained, but once again I'll conclude that one. This one. So the repeatability and reproducibility here. So at the starting for one value, one reading, I will give 0 here. Now input. Next I will increase the input. The output will also increase. Increase the output. Output will also increases over there. First time I have taken the reading like that. So according to the first time, we got the exact at the center point. We got that. Okay. By using the continuously using the instrument, what will happen? Again, I will switch off the instrument, all the meters. Next, I will switch on that one, but it should not show 0 over there. For some input, see here, I will increase the input. I will increase the input, but there is no output at all here. See here, for the second time. Is there any output here? Is there any? No, output is 0, but input is increased here now. Input is increased. This is called dead time. We are going to call that dead time. Then what happened from this point? Again, the linearly the output and inputs are increasing over there. Output and inputs are increasing over there. So is there for the repetition I have done here now? For the repetition, that same answer we didn't got. We have got less now, lesser than that the previous one. Yes. Yes or no? Okay, next one. Just a minute. So that is the value is reduced here now. The output is lesser than the previous one. I will finish that one. I will complete up to that one. Next, what will happen? Again, I will switch off all the things. Next, I will start to take the third reading. It may come here, or it may come here, or it may come here and here. I will consider this one here. At 0 input, it is showing some output value. At 0 input, it is showing some output value. Next, I will increase the input, then output will also increase here. It is there or not? Output is now output is more, but input is 0. At 0 input, some value is there. Okay, that one like that, it is going to increase. Example I can give. Repeatability is nothing but, suppose in the 12th standard, you peoples for the first time you got the exam, what you have written the exam, improvement exam, all of you know. इम्प्रूवमेंट एक बार अच्छा रिजल्ट नहीं आया और एक बार रिजल्ट अच्छा रिजल्ट निकालने के लिए और एक एग्जाम देते ना. यस सर नो?
यस सर.
अभी सपोज फर्स्ट टाइम एग्जाम लिखा है 60% आए, you are not satisfied with 60%. Next again you will write the exam, but it may be 60% or it may be 50 or it may be 80. Yes or no? Plus or minus range is there.
Yes sir.
That is called repeatability. We are going to call. That is called repeatability, or exam chhod do abhi, revaluation you will put. This is the first value, consider that one. You got the marks, this is marks, we got that one. When you put for the revaluation, okay, one valuation is over, and that time this is the value we got here. In the revaluation, you will put that one revaluation, the marks may decrease or increase. Yes, repeatedly
Yes,
they are going to evaluate your papers. So it may be, suppose one subject you got 60 marks, you will put for the revaluation, then what will happen? It may be 55 or it may be 65. Some variation will be there. For both the variation, you should have to agree. Then only you have to put for the revaluation. Like that here, that is called, if the variation is there, first you will put the revaluation, instead of 60 you got 55. Next, what you will do, that one challenge revaluation will apply. I think nowadays they have removed that one. By paying higher amount, you can take the paper and you can take one evaluator with you, and the university will appoint one evaluator. Both will go sit together. They are going to evaluate both together. That is called challenge revaluation. We are going to call that one. And that time, 65 marks you got means that is also repeatability here. They are not getting the same marks over there. That is called repeatability. Suppose if you got the first time, once the result declare, you got 60%, you will put for the revaluation. Again, there is no, again the 60% marks only will get. There is no change at all. Next, you will go for the challenge revaluation. Again, you will get the same marks. That is called reproducibility. We are going to call that. Reproducibility means there is no change in the value or output, but repeatedly they will do the checking like that. Same value of output they are going to give in for the particular input, same output, particular input, same output, like that. That is called the difference between repeatability and reproducibility. We are going to call that. Is it clear? Clear हो गया concept सगळ्यांना?
Yes, sir.
Any doubts? Next topic, I think yesterday we have a resolution. We are going to call that one. If the input is slowly increased from some arbitrary, is nothing but non-zero value, we are going to call that one. It will slowly increase some arbitrary, that is called non-zero value. Non-zero value means, where I have to draw, I will draw here. Okay, this is the output and this is the input here. Non-zero value means there is here somewhere, I will consider that one. This is non-zero value. 0 is here for the input, 0 is this one. This is non-zero value. Somewhat this one value is there here from this one. Non-zero value. It will again found that the output does not change at all until a certain increment is exceeded here. Non-zero value, after some time here, it is going to change. The increment output will be increases over there. Example I have given yesterday, that is called diode characteristics, VI characteristics of diode. For the particular value, it will not changes the output current, we will not get that one. After reaching the rated voltage, suddenly the current output will be increases. That is called, we are going to call as, what we will call that one? Resolution. We are going to call that one as resolution. If the input is slowly increased from some arbitrary input value, it will again found that output does not change at all until a certain increment, until certain value, what is the rated value based on that one, is exceeded here. Now, this increment is called the resolution of the instrument. This instrument is called as, what we will call that one? Resolution of the instrument. We are going to call that one. Next one, a range or span. This is very important. That is very important. We are going to call that one here. The range is there, span is there. Range or span, both are same. Anything you will give that one, some range is there. Suppose, what is the difference between Solapur to Pandharpur? Around 70 kilometers. Around 70 kilometers, na? The range is there, 70 kilometers. And the maximum value and minimum value, we are going to count that one. Yesterday I have told you people, suppose in you started the journey from the So Pandharpur to Solapur, your meter is reading that one, your meter is reading, the vehicle meter is reading 1 to 1200 is there already. Okay, so after reaching to the Solapur, it is nothing but 1270, you will get that one. What is the range here now? What is the kilometer total difference? 1270 minus maximum value minus minimum value will do, na?
Yes.
So 70 is the difference, that in the range of the Solapur to Pandharpur is 70. 70 to 80 we can give, 100 to 200 we can give, 10, 0 to 10. They can give 4 options like that. So based on that, the range, that is called range or span we are going to call. Suppose for the just passing 0 to 30%, the range is there for the passing percentage. Yes, just pass ho gaye abhi. Next 31 to 59%, you'll get second class. This is the range for the second class. 60 to 74, 60 to 74, that is called FC first class is there. 74 onwards, sorry, 75 to last over there, more than greater than 75 is there, that is called first class with distinction. They are going to give the, all some universities, they have their own criteria over there. Is this one we can call it as a range only, na? For the second class, what is the range? For the just passing purpose, what is the range? For the first class, what is the range? For the FCD distinction, what is the range? Like that, every instrument has its range. Why the range is necessary means, suppose emitter you consider to measure the 15, 20 volt, 20 ampere we have to measure, but the meter reading has only up to 10 ampere we are going to measure. Is it possible to measure the 20 ampere? Is it possible?
No.
The meter range is 0 to 10 ampere, but I want to measure 20 ampere. Is it possible?
No.
Not possible.
That is the span or range we are going to call. Every instrument, it has some maximum value and minimum value. Based on that one, maximum minus minimum, by doing that one, we can identify the range of the meter or span of the instrument we are going to call that. Is it clear? In an analog indicating the value of measurand, whatever the measuring value is indicated on the scale by a pointer, while in a recording instrument it is indicated on a chart by a pen and pen mechanism. Recording instruments may, for the first 6 AM, 7 AM, like that, they are going to what is the value recording purpose. Or the minimum and maximum values of quantity for which an instrument is designed to measure is called range or span we are going to call. Minimum and maximum value, they have to mention here now. Suppose one analog meter is there, one analog meter is there. Here, see here, the analog meter scale is like this. Yes, I said it in a meter ka.
Yes, sir.
Here they will give one pointer over there. This is the pointer 0 and it is 10 ampere. A meter means like that here. So whatever the pointer it will deflect here now, that point we are going to identify here. What is the range of this meter now? Range
10
of this 10 ampere, because 10 minus 0, it is 10 ampere only. Instead of this 0, I can write here, it can start from minimum 5 ampere also. 5 to 10 ampere. What is the range of this instrument now?
5.
10 minus 5 is nothing but only 5 ampere can measure. Like that, every analog instruments, it has the minimum and maximum value. So the span or range we are going to measure by maximum value minus minimum value we are going to identify over there. Is it clear?
Yes, sir.
Suppose the highest point of calibration is X maximum. Highest point means whatever the maximum value we are going to call that in an instrument, whatever the instrument we have used here now. So this is 0, this is maximum we are going to call. Maximum is nothing but suppose 200 volt also you can consider 200 volt maximum units. While the lowest is x minimum. What is the lowest here now? This is 0. Lowest here now. X minimum we are going to call this one. This one x maximum is nothing but this is minimum and this one is maximum. Minimum units, and that the calibration is continuous between the 2 points. The calibration means the measuring quantity in between these 2 points only. It may be anywhere here only. It may be anywhere here only it is there. Okay. The instrument span is given by the instrument span or range is given by maximum value minus minimum value. That is called the span or range of the instrument. We are to call that one. We are going to call that. So this is the simple concept of range and span. Is it clear?
Yes, sir.
Okay. Next, we'll go for the next topic. That is called the drift here now. Drift is the gradual shift in the indication. Gradual shift in the indication over a period of time where the input variable does not change. Just a minute. Hello, sir. Okay. So the drift is nothing but the gradual shift in the indication over a period of time where the input variable does not change. अभी हमने resolution check किए. Resolution का कैसे था? If we are giving for particular input, but there is no output at all. Output कुछ नहीं था. But in the drift is nothing but it is completely reverse here now. The what they will do here, some gradual shift in the indication, some value it is detecting here now, but there is no input at all. Input 0 hai. Then also the value is increased over there. The what is the resolution is nothing but there is input is increased here now particular value, but there is no output. But the drift is nothing but at do not change in the input, there is no change in the input, but the output is changed suddenly here now. Output is gradually shift indication over a period of time here now. Over a period of time, particular time period, it is going to increase over there like that we are going to call, where the input variable does not change. Is it clear? That is called drift we are going to call. There is no input. Input change nahi hai, but output change ho raha hai. That is called drift we are going to call that one. Resolution is nothing but we are changing the input, but there is no output. Drift is reciprocal of that one, reverse to that one. We are not changing any input, but the output is gradually shifting over there. Is it clear? Both resolution and drift. Hello? How is that?
Yes, sir.
Okay. Next point is nothing but sensitivity we are going to call that one. It is defined as the ratio of change of input to the change in change of output to the change in input. Suddenly I will increase, suppose I have in any measuring instrument what I have given initially 100 volt I have given. Okay, 100 volt I have given over there. What I will do, instead of 100 volt I will increase to the 120 volt. 120 volt. It is the main instrument should have to read 120 volt on that condition. Then we can say that one it is sensitive. We can say that one it is sensitive. Example, if you are sitting, you are listening the class now. If any ant is biting to you, You are not observing that one. You are not sensing anything. That is, you don't have a sensitivity. If the ant is biting to your hand or to you, then you will be sensitive. If you are sensible, you have the sensitivity, you will feel the pain over there. Immediately you will respond to that one. Yes or no?
Yes.
That is
Yes,
called
sir.
sensitivity. Your body is sensing particular area where the ant is biting. That is called sensitivity, we are going to call. Once it is sensed, immediately your other hand will go to that one. It will hit that one and you will rub that area part of that. That is called speed of response, we are going to call. Yes.
Yes, sir.
Speed of response बोलते ना हमने. If the ant is biting, you are not feeling anything. You will not go to hit that ant. Is nothing but sensitivity is less. Then the input there, it is the ant is biting, but you are not reacting to that one. That is called what we will call that one, resolution. We are going to call that. Yes.
Yes, sir.
So all the things one to another one related, they have one to another, they are related. That is the instrument. We are don't consider the body and all the things. The instrument should be sensitive. Should be sensitive. If we have given the something, one volt to have increased, some 1 point I have increased, immediately it should have to increase. It should have to display that one. If the instrument is sensitive, then it should have to change that one, and immediately the speed of how much time it will take to increase that one, that is called sensitivity. We are going to call that part we are going to call as sensitivity and speed of response. Both are very important for the measuring instruments. Next one, stability. That is the very important part. It is the ability of an instrument to retain its performance throughout the specified operating life. Specified operating life. Ability of a instrument, we are going to call that one. Suppose any instrument you got that one, mobile तुमने ले लिए एक, उसका वारंटी बोलते हैं 1 year वारंटी है. Okay, if within 1 year if anything damaged, means it doesn't have any ability, means the stability is less of that. If nothing is happened after 1 year, 2 years, then the instrument has ability to retain its performance may throughout the specified operating life, which means it has the stability power. The stability is more, we can say that one. Stability. I will ask one more thing, I will tell that one. Daily, suppose in the offline condition in your childhood, you may go to the other villages for the schooling purposes and all. Sorry. For daily 2 kilometers, you are running 2 kilometers up and 2 kilometers down over there. 4 kilometers you went for the school over there. Okay, that is they have the ability. In your childhood, you were having the ability. Now, is it possible to go to you peoples? No, you will not do that one. You doesn't have the ability. If you have that ability, then also will not do that one. So example, best example is your mobile. Everyone is attending the mobile. You are having the mobile. Some people they will change their mobile for the 6 months, 1 year, 2 years. So the span or the range of the or whatever the life of that mobile is nearly they will use 1 year only. Warranty is 1 year only. It may come plus or minus the range they have given. 3 to 5 years they will give that one, the range. How many of you are using 5 years mobile? If anything happened within 1 year, the instrument, the product is not able to handle or retain its performance. Performance damage हो गए तो means क्या है? Battery down हो सकते हैं, performance अच्छा नहीं है, heat होने का. Yes or no? While talking while calling to you people, it will take some delay. Speed of response is less. कैमरा बटन क्लिक करने के बाद 5 मिनट के बाद कैमरा ओपन हो गए तो ऑपरेटिंग लाइफ रिड्यूस हो गए ना नहीं?
Yes.
Operating, that is
Yes, sir.
what it doesn't have the ability. If for the 3 to 4 years it has the lifespan, then nothing is happened, everything is in the operating, then we can say that one, that the product have the stability is more, so it has the ability to retain its performance throughout its specified operating life. We are going to call that. Is it clear? Stability. Clear? Rule number 38. Page 38. Shamde Mahesh. What is the time to join? I will not take your attendance. I will put absent only today. Okay, next one. The last point we are going to discuss, that is called tolerance. We are going to call that. Tolerance is nothing but every instrument we cannot say that one it will give the accurate 100% accurate nahi ho sakte. The closest to the standard value, accuracy is nothing but closeness to the standard value. We are not saying 100%. Closeness is nothing but 97 to 103%. We can call that one. 100% is required, but 97 to 103 we have allowed some error here. No, 100 minus 97 kitna ho gaye? 3%. And 103 minus 100,
3.
3. So 100 minus 10 is nothing but minus 3. So plus or minus 3 error we are allowing. Plus or minus error, it is nothing but error only, na? 100 chahiye humko, but 97% it is showing here now. So 3% error is there. 100 chahiye humko, 103 dikha raha hai, means minus 3% is error now. So plus or minus 3% error is allowable. We are allowing. That is called, we are going to call as tolerance. That is called tolerance. Is nothing but maximum how much percentage of error we are going to allow for the measuring instrument. It should have to show 5 ampere. All instrument it should have to show 5 ampere. But due to some conditions, what will happen? It may show 5.5 or 4.5. That is called error. 0.5 is the error. We are going to tell that. So that is called tolerance. We are going to call that one. So this tolerance, so it completes all the definitions of that one. Okay. So the next point we are going to discuss about the calibration. We are going to discuss. Actually, I have one examination at 2 p.m. So what I will do, I will end the class now here only. At 1:45, the machine subject, they will put the link and you have to attend the class for the next one. Okay. I will end the here only and I will continue in the next class.